All right. Good morning or afternoon, guys. This video is about 7.4. We're talking about solving log equations. And there's lots of ways to do this, but for now we're going to break it up into two different categories. And it's dependent on if you have a single log in your equation or if there are two logs in your equation. There could be cases eventually where there are more logarithms, but for now, the two cases that we're looking at will be that there's either one log or there's two logs. So let's look at an example of one where there's a single log. It would look like log base 9 of x equals 3/2. The steps for a single log equation would be to first isolate the term that has the log. So if there was anything outside of this log, like a coefficient or a constant, you would want to move that to get the log by itself. From there, we're going to switch form. And what I mean by, there's an R in there, is that right now it's in log form, and we're going to write it as an exponential equation instead of a log equation. Okay, and then lastly, once we solve it, we're going to check for extraneous solutions. Okay, so with this example, the log has already been isolated. Okay, there's no coefficient or constants. So now we're going to switch forms. And so that means we want to write it as an exponential. Our base is 9, and it's to the exponent of 3/2, and it equals x. Okay, well that was pretty handy. All we have to do is find what 9 to the 3/2 is, and we'll get our answer for x. Okay, so 3/2 means the power of 3, and then the dividing by 2 means the square root. So the square root of 9 and then cubed is 3 cubed is 27. Okay, so we get an answer of 27. What we're looking for when we check for extraneous solutions is that the base of a log and then the argument of the log, the thing that's inside the parentheses, is positive or non-negative. Okay, so both of those things have to be positive. So if I were to plug 27 in for x, I have a base that's positive and I have an argument that's positive. So this should make a true statement. Log base 9 of 27 does equal 3/2. Okay, let's do one more. Actually, we'll do a couple more. -2 log base 5 of 7x plus 4 equals 6. For this one, we're going to have to isolate the log. To do that, we're going to subtract 4. -2 log base 5 of 7x equals 2. And then divide by -2. So log base 5 of 7x equals -1. Now that the log is isolated, we're going to switch forms. It's a base of 5 to an exponent of -1, and it equals 7x. Okay, 5 to the -1 is equivalent to 1/5. And then to get x by itself, we'll divide by 7 or multiply both sides by 1/7. X is equal to 1/35. And to check for extraneous solutions, I just want to make sure that the base of my original log would be positive and that the argument, if I were to plug 1/35 in, 7 times 1/35 is 1/5. Okay, as long as it's a positive number, I'm good. So this would be my answer. Okay. Last one for this. Don't have much room. log base x of 1/2 equals negative 1/3. The log is already isolated, so we're going to switch forms. It's a base of x to the negative 1/3 power, and it equals 1/2. Okay, I know a negative exponent means 1 over that thing, and then the 1/3 exponent means cube root. So this would be like the 1 over the cube root of x. And that seems kind of ugly to solve for x. So instead, I'm going to use properties of exponents to solve this. Okay. Oh, sorry. There we go. Okay. I'm going to raise both sides to some power such that on the left-hand side, when I do a power to a power, it would multiply to 1. So x to the first power. Okay. So I'm thinking negative 1/3, what could I multiply, or what could I raise this number to so that it equals 1? Okay, it would be the reciprocal, negative 3. Okay, negative 1/3 times negative 3 would be positive 1. So we're going to do negative 3 on that side. So we're going to raise both sides to the negative 3 power. And I know on the left-hand side, a power to a power, this one multiplies to 1. So it's x to the first, and it equals 1/2 to the negative 3 power. All right. That means 1 to the negative 3 divided by 2 to the negative 3. Okay. If both the numerator and the denominator are negative exponents, I can flip them both. So it becomes 2 cubed divided by 1 cubed. 2 cubed is 8 over 1 cubed is 1. So our answer is 8. Okay. I want to make sure that whatever I find, my argument is positive or non-negative, and that my base is positive. So I found a positive x value, I'm good. Okay, so there are our examples for how to solve if you have a single log that you're working for. If you have an equation that has 2 logs, we're going to be using a property of equality, and it's really similar to the property of equality for exponents. So what this property of equality says is log base b of x equals log base b of y if and only if x equals y. Okay, so if you have a single log equals a single log and the 2 logs have the same base, then the arguments of the 2 logs must be equal. You can basically ignore the logs and set the insides equal. So if you had, here's our first example, log base 2 of x squared minus 4 equals log base 2 of 3x. Okay, we have log equals log, and the bases on the logs are equal. That means the arguments are equal. I know x squared minus 4 must equal 3x. So now it's just a quadratic that we can solve. We would subtract 3x, and we're going to put it in between the quadratic and linear term. And you can solve with whatever method you want, completing the square, quadratic formula, factoring, x minus 4 and x plus 1. Okay, so we solve and we get x equals 4 and negative 1. This one as well, we want to make sure to check for extraneous solutions. So what that means is when we plug in a certain value for x, that it would make both arguments true. Okay, so let's start with 4. If I put 4 in this side, okay, 4 squared is 16. 16 minus 4 is 12. Okay, that's positive. And then 3 times 4, that's 12. Okay, so those are both positive. Okay, so I know for sure x equals 4 is a solution. Let's try negative 1. Negative 1 quantity squared is 1, and then 1 minus 4 is negative 3. We have a problem. And then same thing here, 3 times negative 1 is negative 3. So while technically the insides are both equal, you can't take the log of a negative number. Okay, if I asked you, like separately, what is log base 2 of negative 3? Okay, 2 to what power would get you negative 3? There's nothing. There's no exponent that would get you a negative number. So that's why we would say that the argument has to have a positive value. Okay, so negative 1 is actually not a solution, and that's because when we plug it in, it's making the argument negative. Okay, let's try one more of those. Log base 7 of 4k minus 5 equals log base 7 of 2k minus 1. As long as it's 1 log equals 1 log and the bases on the logs are equal, you can essentially ignore the logs and set the arguments equal. 4k minus 5 equals 2k minus 1. We'll solve for k. Subtract 2k and then add 5, divide by 2, get k equals 2. We want to make sure when we plug in that value of k that we get a non-negative argument. So 4 times 2 is 8. 8 minus 5 is 3. 2 times 2 is 4. Minus 1 is 3. Both of those arguments are positive. Okay. All right, so this idea for the argument to be non-negative. You can have an x value, you can have a solution be negative, but just so long as when you plug it in, it makes it be non-negative. Okay. Another thing, sometimes when you get this quadratic thing, maybe one will work, maybe both will still work, maybe neither will work. So that's why it's important to be testing with both. Okay, and in all of these cases, you always want to be checking for extraneous solutions. All right, thanks guys.